Earlier, we talked about weighted graphs. If the edges of our graph have weights, we say we have a weighted graph. These weights can represent factors such as cost, distance, complexity, literally anything. A common application of weighted graphs is in finding the shortest path between two nodes. Let's say these nodes represent different areas in a city, and the weights on these edges represent the distance or traffic conditions between these areas. Soon, I will show you an algorithm to find the shortest path between two nodes. But before we get there, I want you to implement a weighted graph. So create a new class called weighted graph. In this class, we should have a private node class just like before, but we should also have an edge class. This class represents the edge between two nodes. So we should have three fields. From and to, these are both node objects, and weight, which is going to be an integer. For now, only implement two operations in the weighted graph class, add node and add edge. Just remember, this method should have three parameters, from, to, and weight. Also, I want you to make this graph an undirected graph. In an undirected graph, our edges don't have a direction. So if we add an edge between A and B with a given weight, we should also have an edge from B to A with the same weight. So spend 10 to 15 minutes on this and then come back here.